Welcome to the Project Management Prepcast, the direct route to PMP exam success. Here's your instructor, Cornelius Fichtner.
Hello and welcome to the Project Management Prepcast, where preparing for the PMP exam is as easy as nowhere else. I'm your instructor, Cornelius Fichtner. This lesson is all about advanced quality management tools. There are so many quality management tools used in project management, and they are all used throughout the quality management processes. It made sense to lift some of them out and discuss them separately and in more detail here. You may have noticed that we included already quite a number of quality management concepts, theories, as well as tools and techniques in our quality lessons on the various PMBOK guide processes. But don't worry, there's still enough tools left for us to fill this lesson here as well. In fact, it's almost overflowing. In any case, in this lesson, we will provide you with a quality management tools overview, discuss and explain the 7 basic tools of quality, introduce the rule of 7, we discuss run charts, we review additional quality management and control tools, describe statistical sampling as well as the various sampling methods, and we will finish the lesson with quality audits. This is going to be a very unscientific overview of the types of quality tools that are available out there, and generally speaking they all fall into these 8 categories here. We have the cause analysis tools. These are tools to help in the first step to improvement, identifying the cause of a problem or situation. Then we have evaluation and decision-making tools. These are tools which help to make informed decisions and choosing the best option with a simple objective rating system, and tools also to help in determining the success of a project. Next we have process analysis tools. These focus on how to identify and eliminate unnecessary process steps in order to increase efficiency, reduce timelines, and cut costs. And we also have the 7 basic quality tools. These 7 tools get to the heart of implementing quality principles. Next we have data collection and analysis tools. These facilitate collecting the data you need and what you should do with the data once it is collected. We have idea creation tools. These show you ways to stimulate group creativity and organize the ideas that come from it. We have project planning and implementing tools which help you how to track a project status and look for improvement opportunities. And finally, we have the 7 new management and planning tools which help to promote innovation, communicate information, and also successfully plan major projects. As part of quality improvement movements in Japan in the latter half of the 20th century, the Japanese Union of Scientists and Engineers, they were influential in defining a set of basic tools that you could use for improving processes. The PMBOK guide lists these as the 7 basic tools of quality, and they are the subject of much of this lesson. Here they are. We have cause and effect diagrams, flow charts, check sheets, Pareto diagrams, histograms, control charts, and scatter diagrams. In addition to the 7 that are listed in the PMBOK guide, you often find 2 more in various other references as well as in older versions of the PMBOK guide, and we have them here in orange. They are the bar charts and other graphs as well as run charts. So let us begin with the first of the 7 basic tools of quality, the cause and effect diagram. We'll also discuss this in depth in our lesson on the identified risks process. So The cause and effect diagram is a very simple diagram. It's easy to create and use. It is also known as the Ishikawa diagram after its creator, Mr. Kaoru Ishikawa, who first came up with this tool for analysis. But it's also called the fishbone diagram, and the reason for this is, well, it kind of looks like a fish without the meat on it. You'll see why in just a moment. Again, we use this in quality control, but also during the risk identification process to try and determine the root or main cause and contributing risks. Here is an example of such a cause and effect diagram. You see the effect on the right-hand side, and your potential causes are feeding into this from the left. They enable you to illustrate how these potential causes may be linked to the problem that you see. And doesn't this structure kind of look like the skeleton of a fish? An example of where the diagram is very useful in quality is this. Have you ever had a problem, fixed the problem, and then later on you found out that you didn't really fix the main cause and the problem came back again? Well, this points to a lack of trying to identify the real root cause of the problem. And that is what this technique is trying to help you with, finding the root cause. So in quality, finding the root cause and ancillary causes is critical when a problem has been detected. A cause and effect diagram will help you do just that. Next on the list of our 7 basic tools of quality is the flowchart diagram. Yes, it's just boxes and arrows that show a process. Here we have a very simple decision flowchart that helps you figure out why your lamp may not be working. But you could also use this to document and analyze a complete process. For instance, you receive a bill, the bill gets stamped with the receipt date, the bill gets reviewed, entered into the system, approved, and then finally paid. Each of these steps is a box that is connected to the other with an arrow. These process flowcharts can help you predict where and what kind of risks might occur in the documented processes and are used in quality to help estimate the cost of quality or maintaining quality. One of the chief ways that flowcharts are used in quality management is because during quality planning, flowcharting can help the project team anticipate quality problems that might occur. Anticipation is key here, as the flowchart shows the process flow graphically, and most often during the drawing of the flowchart, potential sources of conflict, error, or quality control checkpoints will just simply jump out at you or anyone who's reviewing the diagram. If you get in front of the problem earlier, it's much easier to plan a response before there is a negative impact. Our next tool in the quality management arsenal are check sheets. The check sheet is a simple document that is used for collecting data in real time and at the location where the data is generated. The document is typically a blank form that is designed for the quick, easy, and efficient recording of the desired information, which can either be quantitative or qualitative. When the information is quantitative, the check sheet is sometimes also called a tally sheet. A defining characteristic of a check sheet is that data is recorded by making check marks on it. A typical check sheet is divided into regions, and marks might, in different regions, have a different significance. Data is read by observing the location and number of your marks on your sheet. There are 5 basic types of check sheets. First of all, classification. A trait such as a defect or failure mode must be classified into a category. Second, location check sheets. Here the physical location of a trait is indicated on a picture or a part of an item that is being evaluated. Third, we have the frequency check sheets. The presence or absence of a trait or combination of traits is indicated. Also, the number of occurrences of a trait on a part can be indicated. Then we have the measurement scale. A measurement scale is divided into intervals, and measurements are indicated by checking at an appropriate interval. And lastly, we have the checklist. The items that are to be performed for a task are listed, so that as each is accomplished, it can be indicated as having been completed. Kind of like a shopping list, really. Next up is the Pareto diagram or the Pareto chart. Have you ever heard the expression of the 80-20 rule? Some examples are that 80% of sales in your company come from 20% of your customers, or 80% of all problems in a school are caused by 20% of the students, or that the software package has 80% of the requirements and we will customize the other 20. It was Vilfredo Pareto, an 18th century Italian economist, who observed that about 80% of the wealth in his country was owned by about 20% of the population, and that this pattern repeated itself again and again. The statement of this uneven distribution was then generalized by the American quality guru Joseph Juran as the Pareto Principles, and it is sometimes also called the 80-20 rule. And here is an example of a Pareto chart. This shows you the main reasons why people are late to work in the greater Los Angeles area. As you can clearly see here on this graph, traffic accounts for just a little of over 62%. And since I live in the greater Los Angeles area, I can tell you, yeah, this is not surprising. The traffic here is sometimes horrendous. And this is then followed by another 16% of people who oversleep. Together, these account for nearly 80% of people who are late to work. And why is it good to know this from a quality management perspective? Let's assume that we wanted to do something about the problem that we see here. Which of these problems would you address first? Would you focus on the big ones on the left, or would you go and try to solve an emergency, the weather or the public transportation on the right? Well, of course, you would focus on the big ones first. However, there's probably little that we can do about the traffic problem here in the Los Angeles area, but we could hire a wake-up service who will call our notorious oversleepers and get them out of bed. So the Pareto chart, the Pareto diagram, enables you to focus on the largest problems first. Next in our list of these 7 basic tools is the histogram, which is used to show the frequency distribution of a set of measurements. What you see here is a histogram of data collected by the U.S. Census Bureau in regards to how long it takes people to travel to work. The census found that there were 124 million people who work outside of their homes. And from this chart, we can easily see that most of them traveled less than 50 minutes from their home to their work. A histogram is displayed as a bar chart. The height of the bar represents the number of measurements that fall within that particular region. It is often used when you suspect that there are multiple factors that may affect a process or quality. That way, you can see if and when they show up. Our next basic quality management tool are the control charts. A control chart's purpose is to determine whether or not a process is stable or has a predictable performance. This is done by repeatedly measuring the output or result of the process and then entering it into a timescale. Let's take a look at a control chart and explain what you see here. The green line in the middle, that is is our mean, and our mean is set to 10.058. This signifies that normally we expect our measurement to be close to this number. For instance, if we produce pencils, we expect our pencils to be 10.058 centimeters long. Next, we have the upper control limit at 10.860 and the lower control limit at 9.256. This means that our process will produce pencils with a length in between those two numbers. You can see another set of dashed lines here. These are the upper and lower specification limits. So, now we have all these horizontal lines on the paper, and we can make a dot every time that we measure a pencil. As you can see, the first one was just below 10.0, then the second one was just above, the third one again below, and so on. We make an appropriate dot every time we measure, and we get a graphical overview in time of the results, and we can then begin to analyze that. You may remember from earlier in the Quality Management Knowledge Area lessons that UCL stands for Upper Control Limit and LCL stands for Lower Control Limit. These control limits are always 3 standard deviations from the mean, which means that 99.73 of all our measurements should fall in between these control limits, and anything that is outside would mean that you are producing a deliverable that is outside of 3 standard deviations. And most often, this points to the fact that your process is somehow out of control. There are 4 more concepts that you should be familiar with in regards to control charts. First of all, if one of your dots is way outside of the control limits, but it's the only one, then this may very likely be what we call a special cause. The normal cause or expected variations are all those dots that are between your upper and lower control limits. If your dots are going up over time or going down over time, this is what we call a trend, and this trend should be investigated. And if a certain pattern of dots keeps repeating again and again, this is called a cycle. Again, this should be investigated to see why this cycle is happening. And then we have the rule of 7, which goes like this. What do you do if 7 times in a row the result of your measurements falls onto the same side of your mean? For instance, 7 times in a row the pencil is shorter than 10.058 centimeters. What do you do? Well, the answer is you investigate. I mean, think about this. You produce thousands of pencils an hour, and there is normal variation. What are the chances that you happen to show up every 15 minutes? You pick up a pencil, measure it, and 7 times in a row it is below your mean. The chance of this happening is minute. Therefore, something must be wrong somewhere, and you should investigate. It might be as simple as the measuring device is broken, or it might be that someone is fudging with the process. And then the 7th of our 7 basic tools are the scatter diagrams. Have you ever seen a graph like this one that shows hundreds of dots that are scattered on it? Maybe the x-axis was a traffic density and the y-axis were the number of accidents, and you could tell just by looking at these dots that there was a clear correlation between the 2 factors. Well, you have looked at a scatter diagram, also known as a scattergram or scatter plot. These diagrams help when investigating problems, typically when you're searching for their causes and when you think that there may be multiple factors that are related in some way. The example that you see here is the waiting time between eruptions and the duration of the eruption for the Old Faithful geyser in Yellowstone National Park in Wyoming in the United States. This chart suggests that there are generally 2 types of eruptions. There is the short wait and short duration, which are the ones at the bottom left, meaning if you wait for 5 minutes, you only get a very short eruption, and there are the long wait and long durations, the ones at the very top right. So if you have to wait, say, 1.5 hours until the next eruption comes, it's gonna be a big one. In this way, the scatter diagram helps you to identify the existence of a measurable relationship between two such items by measuring them in pairs and plotting them on a graph. This visually shows the correlation between the two sets of measurements. If the points plotted on the scatter diagram are randomly scattered with no visual pattern, then this indicates that the two sets of measurements have no correlation and cannot be said to be related in any way. If, however, the points form a pattern, like we see here of some kind, then this shows that the type of relationship between the two measurement sets exist. The way they relate to quality is that they can be used to analyze why a problem has occurred and how it might be fixed. Although not listed in the PMBOK guide, run charts provide another tool to assist the quality management process. Similar to a control chart, but without displaying limits, a run chart shows the history and patterns of variation. A run chart is a line graph that shows data points plotted in order in which they occur. Run charts are then analyzed to find trends and anomalies in data that might suggest shifts in a process over time, or special factors that may be influencing the variability of a process. For instance, we notice a problem every day around 9 o'clock in our shop floor, and it turns out that at around 9 a.m. several more machines are turned on, causing a drain in electricity. Run charts show trends in a process over time, variations over time, or declines or improvements in a process over time. Trend analysis is performed using run charts, and it involves mathematical techniques to forecasting future outcomes based on historical results. Trend analysis is often used to monitor technical performance, like how many errors or defects have been identified and how many remain uncorrected, as well as cost and schedule performance, like how many activities per period were completed with significant variances. The first 7 tools are mostly useful for quantitative problems, those with numbers. So a second set of 7 tools was defined for the more qualitative problems that arise, like those that deal with customer needs. Let's take a look at this second set of 7 on a high level. First of all, we have affinity diagrams. This is a group creativity technique that allows a large number of ideas to be classified into groups for review and analysis. For instance, the creation of an affinity diagram can be used to structure the decomposition of the scope from a WBS. Then we have the PDPCs, the Process Decision Program Charts, which are used to understand a goal in relation to the steps required to obtain the goal. These are useful in quality management because they can be used in the planning stages to assist planning teams in anticipating intermediate steps that could potentially interfere with the realization of the goal. Then we have the interrelationship digraphs. These take a group of items, problems, or issues and establish the diverse cause and effect relationships that exist between the group items. This allows you to uncover problems which might have seemed minor, but which in reality feed into a greater number of other problems. Next, we have the tree diagrams. This tool is used to break down broad categories into finer and finer levels of details. Tree diagrams are particularly useful for clarifying the source of production problems. We also have prioritization matrices. This tool can be used for making a decision in circumstances when the criteria can be identified, but the relative significance is either not known precisely or there is no consensus. Prioritization matrices are also a useful tool for assisting project teams in decision-making, like selection of projects, determining measurement instruments to be used to manage the quality processes, and so on. And then we have the activity network diagrams. These are a quality management tool that charts the flow of an activity between separate tasks. It graphically displays interdependent relationships between groups, steps, and tasks as they all impact a project. Bubbles, boxes, and arrows are used to show these activities and the links between them. And finally, matrix diagrams. This is a quality management and control tool used to perform data analysis within the organizational structure created in the matrix. The matrix diagram seeks to show the strength of relationships between factors and causes. Next, we also need to discuss statistical sampling. The idea behind statistical sampling is that if you must inspect your project results to ensure quality, you will not need to inspect 100% of your results, but instead you select a part of the population to be inspected and then you will extrapolate. This is because it's usually enough to look at a certain percentage to come to an overall conclusion. This percentage is often specified as a sampling frequency or a sampling frame in the quality management plan. The goal is to define a sampling frame which will give us a good representation of every single element of our result. For example, if we are producing 1 million pencils, then we will not measure every single pencil, but only every 100th pencil that comes out of the machine. By looking at a smaller number, you can significantly reduce the cost of your quality control efforts. And this is probably the key fact that you have to remember for the PMP exam. By looking at a smaller number, you can significantly reduce the cost of your quality control efforts. The sampling process is made up of several stages. First, we define the population of concern. Then we specify a sampling frame, a set of items or events that are possible to measure. Then we specify a sampling method for selected items or events from within our frame. Then fourth, we will determine the sample size, and next we will implement our sampling plan. This is followed by the sampling and data collection, and in the end we also need to review the whole sampling process and of course the data that we have collected. And if you look at this logically, it's nothing more than the plan, do, check, act cycle translated over to sampling. There are many sampling methods, and here's a list of 12 such sampling methods. Simple random sampling, systematic sampling, stratified sampling, probability proportional to size sampling, cluster sampling, matched random sampling, quota sampling, mechanical sampling, convenience sampling, line intercept sampling, panel sampling, and event sampling methodology. The important fact for us to remember is that there are indeed many sampling methods, and that we may employ the right method at the right moment, and that each of these aims at helping us to avoid having to measure every single item in our population. Inspection is the next tool, and inspection is defined as examining or measuring to verify whether an activity, component, product, result, or service conforms to specified requirements. And there's really not all too much to say about it. It's a primary activity of quality control. You inspect your deliverables. But you should always remember that quality is planned, designed, and built into a result, and inspection is a confirmation that the planning and execution achieved the desired result. And finally, a quality audit is another quality management tool that the project team can use. A quality audit is a structured, independent process to determine if project activities comply with organizational and project policies, processes, and procedures. And the objectives of quality audits may include things like identification of all the good and best practices that are being implemented, identification of all the gaps and shortcomings, sharing the good practices that are introduced or implemented in similar projects in the organization or in the overall industry, proactively offering assistance in a positive manner to improve implementation of processes to help the team raise productivity, and highlighting the contributions of each audit in the lessons learned repository of the organization. There are many benefits that you get from a quality audit. Let's take a look at 3. First, we have reduced cost of quality. This is because the correction of identified deficiencies reduces the cost of quality. Next, we have increased acceptance. The reasoning here is that quality audits can lead to an increased acceptance by sponsors and customers of your project because they see that we are doing something about keeping our quality high. And our last example here, flexible resourcing. By this we mean that quality audits can be done by both internal and external auditors, and we're not bound by any group of people who might be doing this. We are flexible in assigning this to many people. In regards to PMP exam sample questions, it's quite simple. You have to be familiar with these tools. First of all, you must be able to identify the tools. If I show you a scatter diagram, are you able to identify it as a scatter diagram? You must also be able to use the tools in context. If I asked you how to best display the contributions of frequency of occurrence in your sample results, then you must be able to tell me that I should be using a Pareto diagram. Third, you must be able to give the tools their name. If I asked you the name of the tool that Ishikawa created, then you have to tell me that it is called the fishbone diagram, the cause and effect diagram, or the Ishikawa diagram. And lastly, you must know what the tools do. If I told you that the team is currently plotting the relationships between multiple factors on a graphical XY axis, then you must realize that this is a scatter diagram that they are using. And this concludes our look at the advanced quality management tools. Justine?
Ta-ra!
Until next time.